Okay, good afternoon, good morning, or in evening, wherever you are at this moment, dear electrospinning friends, ladies and gentlemen. I'd like to welcome you on the first Elmarco Talks of this year. And actually, this year we are a little bit later than normal years before. We're starting now in March. And the reason is that basically we've been extremely busy at the beginning of this year, which is actually very good news for all of us, because it's a good sign that electrospinning is very interesting and people are interested in our technology and electrospinning in general. So today we have a very interesting talk of my colleague Vojtěch Hýbl. Hello, Vojtěch.
Hello.
I will introduce Vojtěch in a minute. First, I will try to share the slides with you. So what is expected as of today? So today Vojtěch will give a talk. It's an internal talk based on the Elmarco gain experience. And the name of the presentation is From Fiber to Function, where Vojtěch will cover pretty much application with nanofibers. He will go over the experience that Elmarco gained over the years with the different materials regarding the different applications. What is expected to be happen still within this year regarding the Elmarco Talks is the coming, let's say, topic of beautiful speaker, Dr. Vasilis Drakonakis from Cyprus. Is a rather small but very rapidly growing company, advanced materials design and manufacturing. And they are busy with application nanofibers in composites. So this is very unique. And I think it's a very interesting topic. So please keep in touch with us, follow us on the website for the actual date for coming for this Elmarco talk. Next talks are also prepared. September, October, November is all 3 months are already covered with very interesting topic regarding the agriculture, regarding cosmetics and biomedical application. So what Elmarco do? So briefly, I would like to just highlight some facts about Elmarco, although I know that most of you are already well informed. So still Elmarco, 85 employees. We are sort of intermediate-sized company. We are more than 25 years on the market. Actually, last year we celebrated big anniversary of Elmarco selling the electrospinning machines. And we are selling globally. What that means, so we are located, our company is located in Liberec, Czech Republic, where everything is in one place. We have a design, assembly, we have a rather big research department located in this town. Although we work through sales channels around the world, we have a quite active strategic partner in Italy. A lot of activities going on in US. Recently, we really opened Tokyo office, so Elmarco branch office located in Tokyo, where we have also a little showroom. And in this office, 2 people are working full time and covering pretty much this side of the globe, including China, Hong Kong, Taiwan, and other close countries. We have a very busy partner also from Hong Kong. So our sales activities are done pretty much globally. We cover a lot of countries. So how this technology works, so what is actually the principle? So all our, let's say, machines, small one and big ones, are working on the same principle. We are using a wire as a spinning electrode. So this wire is being coated with the liquid. Liquid is basically dissolved polymer in a defined solvent, and by depositing this liquid on the wire and connecting the wire with the high voltage power supply, we generate a lot of fibers. And at the same time, the fibers are coming upwards and are being collected on some moving material, which we call it very often substrate or binder. So basically our technology works with the principle roll-to-roll production. So at the beginning, you have the empty roll of the material, and once the roll is moved through the spinning chamber, and it's covered with nanofibers. It's collected again on the winding system as a sandwich substrate together with nanofibers. So this is pretty much all portfolio of our technology. As I mentioned, we supply small laboratory scale equipment, but of course our main business is form of selling, installing the technological pieces, forming the whole, let's say, solution for the client. So we are supplying not only Nanospider as the core of the technology, but we are supplying also other peripherals, which forms a really like inline part production of fully operated, automated system producing nanofibers. So how do we work with customers? Yeah, it's kind of a little bit of text here. I don't want to read all of it, but I think the message here is that we work very individually with each customer, and maybe nowadays more than ever, we focus on partnership. So we have quite a lot of JDAs project going on, and where we define a clear target. And I think we can work in very efficient way with the clients that because we have experience and we have the knowledge, so we can move and forward your, let's say, ideas with nanofibers into the real, let's say, market. We can bring it to the market much faster and in much effective way if you collaborate with us. We also, part of the services that we offer is so-called sampling process. And basically the sampling process is to verify the capability of our technology, to prove that the technology is working and is delivering the product that you want or that our clients want. For that reason, and not only because of that, but we are recently, and this is actually part of the talk, we have this very beautiful sample books. It's kind of marketing promotion, maybe a little bit, but it covers pretty much all portfolio, or if you want to call it like capabilities of what our technology is capable of in terms of selection of polymers, selection on different, let's say, fiber, achieving different fiber thicknesses of the product in general, maybe forming different composites. So we're trying to categorize the sample into the application categories. And based on that, we are filing these, let's say, examples or case studies in this in one book, which will be or can be freely distributed among interesting people who are interested in. So don't hesitate to contact us anytime, and we are ready to send you samples. Okay, before we really start, just one last thing. I want to invite you all for the technical textile exhibition, where Elmarco is part of. We are exhibiting. It's starting on 21st of April this year in Frankfurt, and we're going to bring pilot scale machines. So it will be very interesting for those of you who've never experienced seeing our technology before. So it's a really good opportunity, and we still have some free tickets for somebody who really want to go. So please don't hesitate to contact us after the talk or anytime from now on. We will offer you those tickets. So enough talking. I would like to give a word to Vojta. So Vojta is a colleague of mine, and I kind of wonder, so how long have you been working with Elmarco, Vojta, already?
Oh, it's already been 5 years.
5 years, yeah. So Vojta is not really like fresh noob, so he's already gained some experience and he has a lot of to share. So what is your original background, Vojta, from your education point of view?
I studied nanofibers on the Technical University of Liberec, where I finished my master's degree, and right now I'm also PhD student.
Mm-hmm. Okay, so it seems that Vojta is really focused on nanofibers, and therefore is the right person to have this talk. So enough of talking myself. So please, Vojta, stage is yours, and you can continue with sharing information.
Mm-hmm.
Thank you.
Thank you. Good morning, afternoon, or evening, dear colleagues and ladies and gentlemen. My name is Vojta, and I would like to introduce you into the topic of my presentation, which, as you can see, is From Fiber to Function, Proven Nanospider Materials and Their Application Potential. What I will be talking about today. First, I will bring some really small introduction to nanofibers and also the samples that we prepared for you. And then I will speak about each of the four main categories in our sample book. First is regarding air filtration, then liquid filtration, performance apparel, and healthcare and cosmetics. So, what's so great about nanofibers? Nanofibers usually, or always, give exceptional surface area compared to the volume of the whole material. Next advantage is that they have quite uniform structure. Actually, they have even better uniform structure, especially on our equipment, which is needleless, which usually makes even more uniform a layer than needle spinning. Tunable morphology, well, we can quite easily tune the diameters of the fibers, and it's very easy for us to tune the thickness of the whole layer. Then there is the possibility of loading with active substances and ingredients, which is also possible, usually also quite easy for many polymers and many other dopants and substances. And easy scale up, since we give quite a big portfolio of different machines, then we are very experienced in scaling up from lab scale to pilot scale and even huge industrial lines. The sample books that we are going to talk about today are tools for discussion and validation of the application direction, which means that none of them are a final product. They are initial example for you to have something in your hands. You can touch it, you can look at it, you can measure it, and we expect some feedback about, let's say, yes, it's good, but we need it more, whatever you want. So it's basically not the final product, it's the opposite. It's the start of the whole process of optimization. The sample books are divided, as I already said, into four main applications: air filtration, liquid filtration, performance apparel, and healthcare and cosmetics. So regarding the air filtration, why are nanofibers good for air filtration? Because they have high filtration efficiency and very small pore sizes, which enables good filtration of bacteria and viruses. And also it's at cost of quite small pressure drop, which is also great. It allows efficient filtration with low energy consumption. As I already said, the area can be functionalized, which allows antimicrobial and pollutant removal properties. Usually in the air filtration field, many products that are already being made are focused on either industrial or HEPA filters. The industrial filters for HVAC are usually of quite smaller filtration efficiency, between 60 to 99% because the main goal for these filters is to have low pressure drop. When we prepare these filters, we usually use a low density of the nanofibers, and we usually get small pressure drop. Then there is the HEPA category, which we also have a sample of. It's quite the opposite, actually. It has very, very high efficiency, 99.95 to 99.995%. Usually at the cost of the pressure drop of 200 to 300 pascals, which is again what our samples achieve. When we prepare HEPA filters, we have to use high density of extra fine fibers, which are quite sensitive to handling. That's the reason why we do the post processes with them. I will talk about it later. Because if there would be any damage to the fibers, it would cause a huge drop in the efficiency. And then there are ULPA filters. We do not have the sample of them in the sample book, but I will mention them anyways. These are the samples that have even much higher efficiencies and are usually at the cost of much higher pressure drop. First sample that we prepared for you is PA6 nanofibers on polyester spun bond. You can see the fiber diameter, pressure drop, and penetration. So the filtration efficiency isn't that high because it's focused mostly on the small pressure drop, which is now 32 pascals. Because of the low pressure drop, it's good base material for lamination. Then here is our HEPA sample. You can see that all the specification on it, and you can see that the penetration is very low at the cost of 252 pascals pressure drop. This sample that we have here is actually a laminate, so it's PET spun bond, nanofibers, and it's laminated between another PET spun bond. So it's kind of a sandwich structure that makes it very durable and more resistant to potential damage. Third sample for air filtration is nanofibers on filtration paper. Again, the penetration is moderate and the pressure drop is quite low. This substrate, this filtration paper, is very firm substrate and it's good for pleating. So that's why we make it on this substrate, this particular sample. Next part of my talk will be the liquid filtration. Main advantages of nanofibers for this field are again high permeability of the filter while maintaining low pressure drop, and again the large surface area that can be functionalized. Small pore sizes allows us removal of bacteria and pollutants. And if we want to make it into membranes or use it as a membrane mostly more than a filter, then the fiber diameters are easily tunable, which enables us to quite easily tune the mean flow pore size. For the liquid filtration samples, we prepared 6 different polymers, as you can see. And all of the samples that we prepare, or from all of these polymers, we prepared 4 different samples. All of the samples has basis weight of 10 GSM. We prepared the finest fibers that we can produce, so the smallest fiber diameters that we are capable of producing, and thick fibers, which are the biggest fiber diameters that we are capable of producing. These again just are 2 opposite samples, and so that you can see that we can prepare them and we can prepare anything in between. Again, it's just starting sample for some optimization. And each of the samples we have either treated or untreated, so it makes in total 24 different samples, and I will briefly introduce them now. First thing is why we do the heat treatment. You can see that on this example of the cellulose acetate nanofiber layer, you can see that we treated it in 5 different ways or 4 different temperatures. And you can see that the air permeability changes, also the bubble point and mean flow pore changes, it decreases. And there is also slight difference in the fiber diameter. You just can't overdo it and use too high temperature, otherwise you will get nothing of the sample, as you can see in the last one that was already degraded. Sample from cellulose acetate. Cellulose acetate, that's a renewable and biodegradable polymer, hydrophilic polymer. It has good permeability, so it's suitable for microfiltration, removal of particulates, bacteria, and organic contaminants, usually from water. You can see the 4 samples that we prepared in the from the cellulose acetate in the table. You can see that the fiber diameters range from 200 to over 400 nanometers. And you can also see how that and also how the treatment affects the air permeability, mean flow pore size, and bubble point pore size. You can also see pictures from SEM. Polyamide 6, that's synthetic polymer, which has good mechanical strength and it's quite chemically stable. High mechanical stability and good wettability makes it a very good polymer for water filtration and oil-water separation. Again, you can see the 4 samples that we prepared. The fiber diameters range from, let's say, 60 to 400 nanometers or anything between we can prepare. And again, you can see how the fiber diameters and the treatment affects the air permeability, mean flow pore size, and the max flow pore size or bubble point size if you want to. Then there is sample for polyacrylonitrile. That's a synthetic polymer which has high polarity and it's also quite chemically stable. It's hydrophilic, which makes it widely used for ultrafiltration, heavy metal absorption, and it can be quite easily functionalized for filtration membranes. Again, you can see that we achieved fiber diameters from, let's say, 70 to 380. And again, you can see that it affects the air permeability and the pore sizes. You can also see SEM pictures. Polyimide, that's a synthetic high temperature and high chemical stability polymer. It makes it good for filtration of aggressive solvents and high temperature liquid processes. Again, table with the 4 samples, small fibers and big fibers, and it affects the air permeability, mean flow pore size, bubble point size. And the last 4 samples from the liquid filtration field are from PVDF, which is synthetic and chemically resistant polymer. It's very widely used in membrane. It's chemically stable and it's used for microfiltration, membrane distillation, membrane desalination, and oil water separation. Again, you can see that we can achieve fiber diameters between 100 to 200 with no problem. And air permeability changes with the fiber diameter and also the mean flow pore and max flow pore sizes. Performance apparel field. Here we have our eco-polyurethane membrane, which will mainly be used in performance apparel field or in the functional clothing. It offers very high breathability combined with the quite good waterproofing. It's light and flexible, which is good because no one wants to wear heavy clothes, and the flexibility makes it quite durable against the wear and tear effect. Why it's called eco-polyurethane? Because it's fluorine-free and it doesn't use any rich solvents during the process. You can see it here. It's a fluorine-free membrane that we produce in polyethylene foil. It can be easily peeled off and then later probably laminated into the clothes. You can see that we achieved water column of over 11 meters at the cost of quite good breathability or quite high air permeability. The basis weight, as I said, is quite low. It's 10 grams per square meter, which is very good for clothing. And the last field is the healthcare and cosmetics. What's so great about nanofibers in the field of healthcare and cosmetics? Well, for healthcare, it's again a high surface area. When it's somehow functionalized, it can make very efficient drug loading and controlled drug release. And also the good breathability make it very good for wound dressings and protective medical materials. There will be one sample from the cosmetic field where nanofibers are good for their skin adhesion, which is quite good due to its thin and flexible structure. The high loading capacity of active cosmetics ingredients again embedders the membrane for the field of cosmetics. It can be doped with vitamins, antioxidants, collagen, hyaluronic acid, or whatever you come up with. Chitosan. We have the sample of chitosan that has basis weight of 2 grams. You can see the fiber diameters here. Chitosan is biodegradable polymer, which is very good known for its hemostatic properties, which means that it helps coagulation of the blood. And it also is antimicrobial, which makes it a great material for some wound dressings to cover the injury. Again, thanks to the nanofiber structure, it has very good and high breathability. Sample from polycaprolactone. Polycaprolactone, again, biodegradable polymer. It dissolves in human body quite slowly, and that's why it's used for tissue scaffolds or for some controlled drug releases when it slowly dissolves and releases the drugs over a long time period. Again, you can see the specification of the sample that we prepared. Then there is polylactic acid, again biodegradable, again dissolves in human body, which makes it again great for the controlled drug release. It dissolves much faster than the polycaprolactone, so it's a similar effect, but in a different speed, let's say, different time. And the last sample is sample for the cosmetic field. This is polyvinyl alcohol, and this sample is doped with collagen, which makes it good for the cosmetics. It can be used for some patches wherever on the skin. Polyvinyl alcohol can be dissolved in water, so you put the patch on your skin and it releases the collagen and then dissolves. The sample has basis weight of 3 grams and nanofiber diameter is around 100 nanometers. Very well, that's all from me for today. I would just again like to say that all of the samples are no theory. They are already prepared, already made. They can be sent to you upon request. They are not a final samples. They are starting point for the optimization. And I would again like to remind you that our goal isn't to prepare nanofibers for you. Our goal is to prepare a machine for you to prepare your own nanofibers. Thank you.
Thank you very much, Vojta, for a very interesting and very fundamental and fully informative talk. I'd like to inform you that there is a Q&A section open. So for those of you who have a question, please type them to this section. We will open it up and answer your question. Before that, or before the questions are accumulated, maybe we can start discussion Because what we've seen, what we hear that there's been quite a lot of work done with all kind of recipes, right? So we went through, I don't know how many polymers we talk about it. So my question to Vojta would be maybe how difficult it is, maybe not talking about scale at this moment, but maybe about the recipe itself. So how long does it take, I mean, to develop, let's say, a good spinnable recipe, let's say from the scratch, if somebody comes to you with some polymer that you never seen before, and you would like to obtain some nice looking fibers. So maybe you can comment on that, on the work which is behind it, you know.
Well, sometimes it's easy, sometimes it's harder. We definitely have to start by finding the solvents that it can be dissolved in. And then we find the right concentration and the right spinning parameters and some additives if they are needed.
Yes, yes. So basically, sometimes it's if the solvent is known that it's sort of easy process, right? If it's not known that we are capable with the knowledge, right, to maybe recommend or find some solvents suitable for this polymer. Okay. How about general scalability, right? So going from, let's say, lab scale to industrial, because I know you've been working a lot with the industrial lines. So how that goes? Because, by the way, most of the samples which are covered in this book, on which machine they have been prepared? Because that's maybe good question. I don't know if that's actually pointed.
I think it's not. Some of them were made on the lab scale and some of them even on the industrial lines.
Yeah, and then cut to this pieces, right? So we have different options, different machineries, yeah, how to prepare it. So back to question, so how difficult it is or maybe easy is to take it from lab scale going to the, 8-wire system, 16-wire system?
Well, it usually almost always starts with the lab scale, and then we need to do the upscaling. Me and my colleagues, we are very experienced with the upscaling because that's what we do, right? We are trying not to only sell the lab machine, but also the industrial lines. The upscaling usually isn't very hard, but some parameters have to be changed to obtain the same final product. So it's not automatic, but it's not that hard, and almost always can be done very precisely.
Okay, thank you. And now we have questions already from the audience. So maybe a question here, what is the largest diameter you can produce in Elmarco machine and with what polymer? Roughly.
Oh yeah, it really depends on the polymers. So with some polymers, we are definitely not able to prepare thick nanofibers.
Yeah, question is what polymer can offer the thickest
largest
fiber? Yeah, the largest.
If I can go off the sample book, there's a polymer which is called PEO, polyethylene oxide. That's not in the sample books, but usually produces really thick fibers. Definitely over 1 micron.
Okay.
But regarding the ones in the sample books, let's say 60 to 80 nanometers, definitely. Acetylcellulose, again, it can be around 1 micron.
Thank you. Next question. Is there a reason that PET substrate was used for the air filtration composite? Was there a substrate used for the liquid, or what would you recommend? Now we are getting to questions that we discussed just before the talk, that there are different substrate used for different applications. So maybe Vojta can comment on that, why we select the PET substrate for, let's say, air filtration, and what would be useful for maybe different application?
Well, in the air filtration, we are We have our samples in the sample books mostly on the PET substrate, but we are capable of producing it on very huge variety of substrates. We have many customers who want their own substrate, and it can be from very different polymers or very different materials. We simply chose the PET spun bond because it's easy to get and it works fine. So why change it? And regarding the liquid filtration, these samples are all produced on a siliconized paper, so that they must be peeled off, so it will be used as a self-standing membrane.
Right, but if somebody is spinning it also on some material which they don't need to peel it off, that can be also done, right? On some selection
Sure.
of other
We can spin on a huge variety of materials, but we have a huge variety of materials as a substrate and a huge variety of the polymers in the sample books. And we definitely cannot do all the combinations just for the sample books.
So it's possible.
Definitely it can be optimized, but it's...
Okay, thank you. Now question about the 10 GSM. You know, you talk about the 10 GSM sample, especially for liquid filtration. So the question here is from a listener. What is the typical basis weight for the nanofiber application, if this 10 GSM is typical, and why we select this 10 GSM for liquid filtration?
For liquid filtration, we chose the 10 GSM because it's quite common, but again, these are just samples for start of the individual research or on the optimization. So we can definitely change it quite easily. I would say that in the liquid filtration, the 10 GSM is quite commonly used. Maybe we could go a little higher, maybe 20 GSM. Sure. Regarding the air filtration, the amount of nanofibers is much lower. It should be around a half of the gram to 2 grams maximum, I would say, per square meter.
And I think the main reason is because you want to maintain certain airflow through such a membrane. You don't want to generate very high pressure drop, so therefore you cannot have very thick membrane for the air filtration. Thank you. Next question. Is there any biocompatibility test results available for PLA or polycaprolactone membranes? Biocompatibility test results?
No, not from our side.
No, right.
Unfortunately.
Well, we try to work. I know sometimes we focus on polymers that has some, like, let's say, FDA approved certification. I'm not saying it's similar to biocompatibility, but maybe in some application, yes. If you want to do it for the medical application, we can work also with different grades of such polymers, right? How do you control environmental parameters, temperature and humidity, so that we can decrease or increase these parameters? So maybe there are actually two questions, as I see now, because the person is asking about the changing the parameters, but parameters... the parameters of humidity, maybe that's okay.
Yes, probably.
Okay.
During the spinning process, well, because we have the AC units, the air conditioning that we also make as Elmarco. These parameters are quite crucial for some polymers, and you need to control it precisely. So that's why we make our own air conditioning units that are usually able to hold the right parameters that we want.
Yeah, it's very important, especially for if you look at the industrial scale technology, when we run 24/7, then definitely we need to keep the conditions very stable, and we need to have a continuous, let's say, income of the air of required parameters as humidity and temperature. So we, as Elmarco, delivering also those units. Very nice question about the lamination. So you mentioned that we have lamination means, let's say, nanofibers protected or laminated between layers. Could you please elaborate on that and the most common mechanism of electrospun nanofiber damage during handling or processing and how it can be mitigated?
So that's probably about the HEPA sample,
I mean, it's generally, I guess, about, let's say, we mentioned that we need to laminate some protective layer on the nanofibers. So what is the most risk, let's say, if this is not happening?
It depends, again, between some polymers. Some are different. For some of them, we use the substrate, the base material. Then we apply some adhesive, then nanofibers, and then again adhesive and the second layer of the substrate. Sometimes we go without the adhesive because it can be melted together just by the parameters of the polymers used. Regarding
We're still on this question?
Yeah, sure. And the handling, well, the best way to not damage the sample is to use the inline lamination, which means that from the Nanospider it will go straight into the laminator and laminate all together. Because if it's damaged, it's usually by the handling that does the operator, the person, right?
Right, and then I think inline lamination is something that we as Elmarco are also looking into it and be very aware that it's very needed, let's say, treatment for specifically for some applications. So we also spend some time doing that. Next question. So do you find that Elmarco machine substrate plus substrate can make the end product, or will need to add another performance structure for the end product? Yeah, it depends what the end product is.
Yes, it really
very,
depends.
Very tricky question. But if I may answer, so for example, for some products, I mean, you don't need to do anything else. You can just have a nanofibers deposited on the substrate, and that's it, pretty much. Yeah. For some different products, you may need to delaminate, or not delaminate, but peel the nanofiber layer off the material to be workable as a self-standing membrane later on. But so that's something that it's based on, let's say, a final application of the customer or somebody who has the idea. But basically, if you're asking about to start with, yeah, then Nanospider plus the substrate is the kind of beginning tool to start your research. Yes.
But for example, for the air filtration, we can quite easily apply the adhesive on the substrate. So we put the substrate, then apply the adhesive, then the nanofibers, and the adhesion is quite good. It's actually very good. And some of our customers use it as filters, just like that, just as it is.
And then maybe we can continue with the next question, because that's about what is the lamination technique we actually use for PA6 nanofibers thickness. So then maybe, well, we're widely using the water dispersion adhesion. Maybe that's something we can mention, like the adhesion module that we are using. Yeah.
Yes, sure.
Command is like glue, basically. We can
sure.
comment on that.
Together with our machines, you can obtain these adhesion modules that we also make, which just apply some water dissolved adhesive to the substrate, Then come the nanofibers, and then there is drying process. So it gets better cohesion of the or adhesion of the fibers on the substrate. But I think that this question was regarding the samples for liquid filtration.
Oh, okay.
So we produce all of the liquid samples are produced on the siliconized paper because they will be later peeled off and used as a self-standing membrane. And so we produce it on the siliconized paper, and then we just let it go through the lamination process. The temperature, it's written in the sample book somewhere. For the PA6, we used 200 degrees, if I'm not mistaken.
Okay. Okay, thank you. So how does the breathable nanofiber membrane compare with Gore-Tex? That's very tricky question to answer, right? Because, yeah, do we have some experience like that?
The breathable nanofiber compares to Gore-Tex. Well,
in what parameters? Yeah.
Well, probably
breathability. Like
that's the nanofiber membrane, so it's probably the ecopolyurethane membrane, I would guess. Regarding the water column, it's, I would say, similar. The breathability for the nanofibers would be probably a little bit lower. Gore-Tex, it's a great product, yes, definitely, because it's made from the Teflon, right? So since we cannot longer work with that, then we have to use other ways, and the polyurethane ecomembrane is definitely a great way.
Okay. So the next question. There are a lot of questions. Thank you for that. Also, can you set some samples if I want to test for some different application, let's say academic or research? Yes.
Sure. That's why are we here?
Definitely. We'd like to. So maybe it was not clearly mentioned that these samples are not really meant just for the industrial partners, but for as Vojta already said, there are just it's just like beginning of the journey, right? So that should offer you some capability of our technology to demonstrate the quality, let's say, of material that we are able to make, that should demonstrate, let's say, the feasibility of this particular polymer or composite you want to design. So definitely be ready to send it to everyone. Next question. So what substrate do you suggest for polymers like cellulose acetate besides siliconized paper? Yes, it's a very frequent question. What should be as a replacement of such a great, siliconized, we call it sometimes baking paper. So if you can comment that.
That depends on the application, obviously. You can use cellulose acetate for air filtration also. Somebody does that. So then you put it on the substrate that is breathable and use it as a composite. It's biodegradable. Maybe there is some way to use it in the medicine, in the healthcare field. I'm not sure. Probably yes. So if you come up with something, we can try it. We can work on it. But for the polymers, well, these are for liquid filtration. The cellulose acetate that I mentioned was for liquid filtration, which means that it's supposed to be peeled off before use. So I don't see any downside of using siliconized paper. Also, we can use polyethylene foil.
Yeah, that's what I want to mention, because on the video, Vojta has been demonstrated, easily peeling off some of the membranes from polyethylene foil. So that could work as a replacement for the siliconized craft paper. Next question. The treatment you mentioned increased the fiber diameter quite significantly. And for polyacrylonitrile, it seems that it helped with the polymer beads. What treatment do you perform on these samples?
I would just start by, because I didn't clarify probably exactly the pictures. The picture wasn't before treatment and after treatment. These pictures were small fibers and thick fibers. That's why the second one doesn't have the beads, because it's thicker fibers. So sorry for the misinformation or not clarifying it. But it's not after treatment. It's the thick fibers. And increase the. Oh yeah, sure. That's the probably the answer for the question.
Yeah, because it should demonstrate that we can easily increase or decrease fiber diameter. Yeah, by that treatment. I mean, obviously decrease, but we can tune the fiber diameter in a way that it's wanted for this particular application. So that should be a message for it. And the beads, I think they simply depending on the different factor. Yeah, usually it goes together with concentration mostly.
Yeah,
the beads,
mostly.
The beads. So all right. Next question. What type of adhesive do you use for preparing laminated material for air filtration? Could flammability of the laminated materials due to presence of the adhesive be a problem? So flammability of laminated materials. I don't know if you ever take care of the flammability.
Yes, me neither.
Regarding selection of materials. I don't know what to say.
Me neither. I'm not sure how flammable is the adhesive that we use. It's commercially it can be bought. It's water dissolved glue, and after it dries, then it's it's glue. Or for some applications we use different polymer that has smaller melting point. In the like when we know that we will be laminating it, we can use different polymer. When we want to just apply the adhesive and keep it together by drying, then we use this glue.
Yeah, thank you very much. So summarizing basically all that, we as Elmarco prepared the sets of sample to really demonstrate the versatility of our technology. So everyone who is interested in, please get in touch with us, and we will be more than happy to send you either the whole book with representing, the different applications, but to be more focused and then really fulfill your, let's say, area of interest, we can even send you just application you are interested in the most, because we have them divided into sectors. Please send us your request on the email address sales@elmarco.com, which will go to the regular, let's say, mailbox, and we will definitely pick your request and distribute the book to you. Or with any other question, please contact us. You know where to find us. All right, I guess we are nearly, or maybe we have still 1 minute. Very last question. Have you ever tested fire retardant additives in the electrospun membrane? Fire retardant.
Yes, we have actually. We now have some customers that are interested in it, and I must say that it wasn't very easy. There is many fire retardants that are commonly used in the bulk material, but they don't work that well in the form of nanofibers. But we were able to find quite few solutions that are, I would say, acceptable, or where it works as a fire retardant. Yes.
Perfect. I guess we are nearly at the end. So since there are no more questions on the Q&A session, and also time is running quite fast, so I would like to thank you all for listening. Thank you for following us. I really encourage you to send us emails, send us your requests, send us your ideas, because we are really interested in your ideas, and we are here to help with nanofibers, with nanofiber production, let's say. And definitely see you on Tech Textile. If you want to see us in real, if you want to see the technology running, please come to our booth of Tech Textile in Frankfurt, 21 to 24 April. So again, thank you very much. Thank you, Vojta, for a very nice and informative talk. And yes, keep spinning. Thank you and goodbye.
Bye.